The last inverse function that we'll define is the arctangent function. So this is very similar to the arcsine and arc cosine process that we've already talked about. Well, let's first look at the tangent function. Okay? Remember, the tangent function has all of these asymptotes at increments of pi halves, at odd increments of pi halves. Definitely, this is not a one-to-one function. It definitely fails the horizontal line test. So we're going to try to restrict the domain, okay, and just grab a piece of this function, and then we'll talk about that piece as a one-to-one function. Well, notice, if I just look at this particular part of the function and nothing else, that function is one-to-one. That little piece passes the horizontal line test. Remember, these are asymptotes, and that's at negative pi halves, positive pi halves. So if I restrict the domain in between there, I get a one-to-one function. Okay? So there is my tangent function that's one-to-one. So we're restricting the domain between negative pi halves and pi halves, but not including. Okay? So let's write this down. Let's let f of x equal tangent x for x strictly between minus pi halves and pi halves. Notice there's not an equal sign here. X cannot equal negative pi halves. It has to be bigger than negative pi halves and less than pi halves. All right? So if we let tangent f of x equal tangent x on this interval, then f is one-to-one. So there exists an inverse function, and we'll define it as f inverse of x equals tangent inverse of x, or arctangent x. Okay? So what's going to be the domain and range of these things? Well, we said we're going to have tangent x defined on the interval minus pi halves to pi halves. Notice we have open parentheses here. Means we're not going to include the endpoints. The range is negative infinity to infinity. Okay? Therefore, since this is one-to-one, it has an inverse function with domain negative infinity to infinity and range negative pi halves to pi halves. So let's take a look at the arctangent function. Here it is right here. I went ahead and drew some horizontal asymptotes. Okay, this just means the function is going to get closer and closer to these horizontal lines but never actually touch. Let's investigate the domain here. Function goes on forever. The domain are the x values, negative infinity to infinity. The range is going to go from negative pi halves to positive pi halves, but not including. So there's our nice arctangent function. Okay? Let's try to evaluate a couple problems here. All right. Again, we're going to define the arctangent of x as the angle on the interval minus pi halves to pi halves whose tangent is x. For example, let's figure out the arctangent of 1. So what I'm going to do is I'm going to draw a circle. I'm going to look for an angle in between minus pi halves and pi halves, so some angle on this interval, okay, such that the tangent is 1. Well, we must be talking about an angle in this interval since we have a positive value here. So let's figure out what angle has an opposite over adjacent of 1 over 1. And that's our nice little 1 root 2 right triangle. So the angle whose tangent is 1, remember what angle that is? That's a pi fourths angle. Okay? If we look at our diagram here, our graph, the arctangent of pi fourths, the arctangent of 1 is going to be pi fourths. Okay? So we plug in a 1 into the arctangent function, it will spit out a pi fourths. Let's try another one. Evaluate the arctangent of negative 1 over root 3. Again, I think it's easiest to just draw a circle. Okay, I'm looking for an angle. Remember, the arctangent, arcsine, and arccosine are always angles. I'm looking for an angle somewhere between minus pi halves and pi halves, whose tangent is negative 1 over root 3. Well, it can't be in quadrant 1 because everything here is a positive value. So it's got to be an angle somewhere down here. So I'm looking for that angle. So let's figure out the angle whose opposite over adjacent is negative 1 over root 3. Remember, that's our nice little 1, 2, 3 right triangle. Okay. Remember the angle that has to be here, that has to be a pi sixth angle. Since we're in the negative direction, that's going to be a negative pi sixths. So the arctangent of negative 1 over root 3 is negative pi over 6. We could check that. The tangent of negative pi over 6 is negative 1 over root 3. All right, let's try a couple more problems. Okay, again, the nice property of inverse functions is that if we compose them, we'll always get x. So the tangent of arctangent of x equals x for all x in the domain of arctangent. On the other hand, arctangent of tangent x is x for all x in the domain of tangent. Okay? Note, tangent of arctangent is x for all x, since the domain of arctangent is all reals. Remember, x can be any value for the arctangent because the domain is all reals. So, for example, if we looked at this problem, tangent of arctangent of 100, well, that's got to be 100, because 100 is definitely in the domain of arctangent. In fact, any value that we put in here, maybe 5 million, tangent of arctangent of 5 million, you know, that's going to be 5 million. Okay? Let's do a little trickier one. Let's evaluate the arctangent of tangent 7 pi sixths. Okay. Well, let's take a look at our tangent function first. Go back. 7 pi 6 is somewhere out here. Okay. 7 pi 6 is not in the domain of our tangent function. So I can't say that this equals 7 pi 6. Okay. It's very important that we know what the domain of these things are. So again, let's try to figure this problem out. First thing we'll do is figure out what the tangent of 7 pi 6 is. Let's see, 7 pi 6 is an angle about to here. Right, there's 6 pi 6 plus another pi 6. Okay. So therefore, this is a little pi 6th angle. And I know that I have a 1, 2, square root 3 right triangle. Okay? So the tangent of 7 pi 6 is opposite over adjacent, which is negative 1 over negative square root 3. So I've simplified this part. Notice that I have negative over negative, so that would become a positive. So we've simplified from this step to this step. Now, what we're looking for, we must find the angle between negative pi halves and pi halves whose tangent is 1 over square root 3. So let's draw a circle. I'm looking for an angle somewhere between minus pi halves and pi halves, okay, whose tangent is 1 over root 3. Well, that has to be some angle in this interval because I have a positive value. Again, I know my special right triangle. and this angle must be pi 6. Okay? Therefore, arctangent of 1 over root 3 is equal to pi 6. Okay, so we've done the arc sine, the arc cosine, and arc tangent. They're all done the same way. What you have to do, you have to make sure that you know what the domains of these inverse functions are and the ranges. That'll help you evaluate these things.